So in the next setup, first we have finished 1A. So second 1B is nothing but if I have to calculate the same thing for this kind of a tapered block, it will be really tough for us to place this entire sine bar over here. If I keep it over here, it will not be proper. So there will be some distortions over here. If it is more small also, it will be a big issue. So for this, what we're going to do is, we're going to place this entire block over the sine bar itself, right, like this. So there is a tapered angle over here, so everyone can able to see that. So what you are going to do is, we're going to rise either one side of the roll, but the problem is we have to place this block correctly on which side we're going to increase the height. So which side means in this particular roller there is no blockage, so this sine bar will be able to roll very easily. But on the other side there is a block here, so if I'm going to move like this, there is going to be a distortion, so I cannot add slip gauges on this side. So the other side only will be able to add this. So what I have to do is, I'm going to place the height in such a way that this is placed it. So the height is taller this side and the height is smaller. So when I'm going to add some slip gauges over here, what happens is the height increases, so this surface will have a flat base. So how this flat base is going to be measured is with the help of dial gauge over here. So we're going to place the dial gauge, make sure we're going to move it along the surface so that there is no change in the value. So whatever values can be here in the dial gauge, but it should not be, it should remain the same within 10 units. So your approximation will be much more better. So let me add a slip gauge first. So I'm adding directly 30 mm slip gauge first. So this is how you add it. So since we are adding on the left hand side, we are placing the block over here. So this is the taller side. So let's say how your dial gauge works. So we are going to place your dial gauge over here. So I'm just going to press it so that it is going to touch, it is going to have some values. So let's say it's showing 60. So but when I'm moving over this side, the value starts to decrease so that it is not touching at all. So it means that this side is still much more taller than the other side. So what I can do is, I can add another set of slip gauges. So you're gonna add slip gauges one by one to find out the height. So just for your purpose, we are adding directly the same height over here. So let us try to measure the flatness now. So I have added another slip gauge over here. So I've kept the values. So I'm just trying to move it. So there is a marginal change, but the change is much more lesser. So if it is less and much more approximately moving within 10 mm only, means yes, the surface is flat. For further more accuracy, we can add much more other slip gauges also to measure the height. So from the slip gauges, you can measure your height. Once you have measured that particular height, so h value is found out. So next is your direct formula. So for the previous experiment, we have said h2 minus h by L. So for this particular one, 1B, you have found out the h using the slip gauges. So sine alpha is equal to h by L. So if you calculate it, you will find the alpha angle. What is the tapered length? You can find it out, right?